Good day, everyone. So we're going to start now our discussion regarding the electric current and Ohm's law. Okay, so for our topic outcomes, these are the outcomes. First is to define fundamental quantities. Later on, we're going to explain the concept of electric charge and its relationship to electric current. Next is to define potential difference and resistance. Then next is identify the standard units for current, voltage, and resistance. Another outcome is to explain the current flow. We're going to differentiate between the electric flow and the conventional current flow and describe the mechanism of charge flow through a conductor. After that, we'll proceed with this. We're going to apply Ohm's law, state the mathematical relationship between voltage, current, and resistance, then manipulate the formula to solve for an unknown variable given the other two. So we're going to go back to what? To the V is equal to IR. Remember that in your Physics 105, we talked about this one already. Okay? Or you talked about this one already in your past courses. Okay? Next is analyze simple circuits, calculate the current, voltage, or resistance in a basic series circuit consisting of a DC source and a resistive load. And calculate electric power using P is equal to IV, P is equal to I squared R, or P is equal to P squared over R. Okay, so now we're going to start with this. Electron drift velocity. Suppose that in a conductor, the number of free electron available per cubic meter of a conductor material is N, and let their actual drift velocity be V in meter per second. Now, in time dt, the distance traveled would be V times dt. So ngayon, no, if A is area of cross-section of the conductor, then what we're going to do is to simply multiply them. The volume becomes what? The velocity itself times the area. So that becomes the the number of electrons contained in the volume is the VADT. Okay, so let's just put that leave lang that equation in that matter. So ngayon maybe you're thinking about how does this flow of electron are being pushed. Okay, so eto, no, how are they being pushed? So later on we'll talk about that one. Okay, kasi tawag ko dito, no, later on we'll talk about the electric potential. Now regarding this, all these electrons will cross through the conductor cross section in time dt. Ngayon, if E is the charge of each electron, remember in your electromagnetism, no, that the charge itself or the electric field intensity, then the total charge which crosses the section in time dt is dq is equal to NAEV dt. Since current is the rate of flow of charge, so I is dq dt. It is given as we just need to to express this one in differential form, no? Not in differential form, but in derivative form, such that we need only to get the dq dt of this part. Okay? And we'll get there what? The current density as J is equal to current I over the area as NEV. So, that's for the electric drift velocity. Now, the charge velocity and the velocity of field propagation. The speed with which charge drifts in a conductor is called the velocity of charge. Its value is quite low, typically a fraction of a meter per second. I hope that by this time you're imagining that it's the flow of electron. No, there are electrons that are flowing through the conductor. However, the speed with which the effect of EMF is the electromotive force. Okay, this is what we call the electromotive force. You need to remember that voltage is a pushing force. The voltage itself pushes the current, and that's the reason why the current is flowing. Now, it is experienced that all parts of the conductor resulting in a flow of current, and it's called what? The velocity of propagation of electric field. It is independent of current and voltage and has high but a constant value of around 3 times 10 raised to 8 meter per second. Okay, so that's for the charge velocity. Now, in the figure shown, a simple voltaic cell is shown. It consists of a copper plate known as anode and zinc rod, which is the cathode, immersed in a dilute sulfuric acid contained in a suitable vessel. The chemical action taking place within the cell causes the electrons to be removed from copper plate and to be deposited on the zinc rod at the same time. Okay, so you may notice there that the flow of current is from the zinc itself, this one, okay, and this is the direction of the electron flow, that arrow itself that I am writing as red, okay, and it goes back to the copper itself. So meaning to say, there is a particular entity there or force that pushes the electron, okay. Now, this transfer of electron is accomplished through the agency of the diluted H2SO4, which is known as the electrolyte. The result is that the zinc rod becomes negative due to the deposition of the electrons on it, and the copper plate becomes positive due to the removal of electrons from it. The large number of electrons collected on the zinc rod is being attracted by the anode but prevented from returning it by the force set up by the chemical action within the cell. So I just wanted to see this one now, but if the two electrodes are joined by a wire externally, then electrons rush to the anode, thereby equalizing the charges of the two electrodes. However, due to continuity of the chemical action, a continuous difference in the number of electrons on the two electrodes is maintained, which keeps up a continuous flow of current through the to the external circuit. Ngayon, think of it as this one. The action of an electric cell is similar to that of a water pump while working, maintains a continuous flow of water as such that water current through the pipe as shown in the right. Okay? So, tawag ko dito, there is this one. There is a pushing force from the water pump itself. Okay? So, from here, from the water pump, there's a pushing force going here. And that's the reason why the water is flowing. Kasi the complexity when it comes to understanding the circuit itself is that we don't see the electron. However, if we visualize it like as water flowing, no, we can get a glimpse of somehow an understanding of this one. Okay? Next to it is this. It should be particularly noted that the direction of the electronic current is from zinc to copper in external circuit. However, the direction of conventional current, which is given by the direction of the flow of positive charge, is from copper to zinc. In the present case, there's no flow of positive charge as such from one electrode to another. But we can look upon the arrival of electrons on copper plate, with subsequent decrease in its positive charge as equivalent to an actual departure of positive charge from it. Now, when zinc is negatively charged, it is said to be at the negative potential with respect to the electrolyte. Electrolyte was the substance earlier I've shown you. Whereas anode is said to be at positive potential relative to the electrolyte. Between themselves, the copper plate is assumed to be at higher potential than the zinc rod. The difference in potential is continuously maintained by the chemical action going on the cell, which supplies energy to establish this potential difference. So, let's have some of the problems here, okay? So, ngayon, it says there for number 1, a conductor material has a free electron density of 10 raised to 24 electrons per cubic meter. When a voltage is applied, a constant drift velocity of 1.5 times 10 raised to negative 2 meter per second is attained by the electrons. If the cross-sectional area of the material is 1 square centimeters, calculate the magnitude of the current. Take note that the electronic charge is 1.6 times 10 raised to negative 19 coulomb. Okay, so let's use the formula earlier. We were given there as I is equal to N. Okay, so tawag ko dito, no, number of electron area times E times V. Okay? So, and there was what? 10 raised to 24 electron. Okay? So, that's the first one. And then times the area of 1 square centimeter. And then after that, um, tawag ko dito, no? But we need to convert this one to meters. So, we have to multiply this one by 100 centimeter is to 1 meter and then squared. Okay? And then next is the electronic charge of somehow this is constant, no? 1.6 times 10 raised to negative 19 coulomb. Coulomb, actually this is coulomb per electron eh. This is coulomb per electron. That's the actual unit for that. Wait lang, I'll put it in this way. This is coulomb per electron. Okay? And then multiplied by the velocity of 1.5 times 10 raised to negative 2 in meter per second. Can I write it to continue here? This is 1.5 times 10 raised to negative 2 in meter per second. Okay? So that's it. Okay, so once we calculate them all, tawag ko dito, no, the electron will be eliminated as well as the centimeter and the meter as well. And then what will happen is patitira dyan is coulomb per second. Remember that the coulomb per second is ampere as well. Okay? And of course, the answer here is 0.24 coulomb per second or 0.24 amperes. Okay, so that's it. That is our answer for this part. Now, another thing is that find the velocity of charge leading to 1 ampere current which flows in a copper conductor of cross-section of 1 square centimeter and the length of 10 kilometers. Free electron density of copper is equal to 8.5 times 10 raised to 28 per cubic meter. Now the question there is, how long will it take the electric charge to travel from one end of the conductor to the other? Okay? So, of course, from the formula, the velocity there, actually, let's make it small v. Ayan. The velocity is the current over NAE. Yan. So, that's it, no? So, if we have a 1 ampere current, 1 ampere, all over the number of electron is we have there free electron density of 8.5 times 10 raised to 28. So 8.5 times 10 raised to 28. Ano na to, no? This is electron per number of electron per cubic meter. Okay? So, and then multiplied by E or the area area of what? Of we have there 1 square centimeter. So 1 is square centimeter, but we have to convert this one again to square centimeter, a square meter. Okay? And then after that, tawag ko dito, we have to multiply itong ilalim by what? 1 ampere here. um by E, which is we are given this value already, as what, 1.6 times 10 raised to negative 19 coulomb per electron. Okay, so this quantity is the continuation of the quantity in the denominator. So we now have there, eliminate the electron, the square centimeter and the cubic meter, and um we'll get there, uh, okay, the velocity of meter per second. Okay, because the coulomb is ampere is coulomb per second, so we can eliminate the coulomb, and then one of the meters here will go up. So the answer is 0.735 micrometer per second. Oh, please check your calculator if we got the same, ha. Okay? And but the question there is, how long will it take for the electric charge to travel? So we have there, the time is the distance of 10 kilometers, 10,000 meters divided by 0.735 times 10 raised to negative 6 meter per second. Okay? And apparently, this is 1.36 times 10 raised to 10 seconds. Okay? But for some reason, no, this is a big amount. So it's better for us to express this one in in larger units. So let's convert this one to, possibly we can use years, no? So we have there, we have, di ba? Um, we have 3,600, ay hindi, 60 seconds for 1 minute, and 60 minutes for 1 hour, and we have 24 hours per day. Okay? And so how many days would it take? Okay? So let's calculate this one. Okay? So we have there, this is a really large amount. Pero I guess I can continue it here above, no, such that we have 157,407 in 41 days. If we want to convert that in years, then let's multiply it more by, we have 365 days, assuming that it's what? It's the regular year for one year, 1 hour tuloy. And finally, we'll get the value of this one as 431.25 years. So this is the correct answer. How long will it take the electric charge to travel from one end of the conductor to the other? Okay? So that ends our micro video lecture, and then the continuation will be on the next part. So see you next video.